This project is a linear regression project in two variables. You need to go out and collect some data and compare two things like height to jumping distance, or I don't know, find two things that you can compare, see how they relate to each other, because you're looking for a relationship that's linear between your x and your y, or your independent and dependent variable. The groups can be no more than 3 people because you need to make sure that everybody has to have a project. This will force you to work in some groups. You may not be very good at working in groups, or you may have had bad experiences with groups. Your teacher will help you to navigate that. But you do need to learn how to work in a group situation, because when you go out and get a job someday, you're not going to be able to say, I don't want to work with my team. If that happens, there's a good chance you'll have to get a job someplace else, because employers don't want to be told you cannot work with a team, and it may take some effort and some, maturity and work on your part to figure out how to make it work. Everybody should participate. You need to be a good team member so that you're helping your group. Okay, so once you've collected your data, you're going to go ahead and put it in a chart, and then make sure it at least has something. It's not too curvy. If it's a little bit curvy, that's fine. But if it's super curvy, then you probably want to pick something else. Anyway, so you collect the data, organize, and display it. Now what I've got here is 2 different ways to display it. You need to display it in a Microsoft PowerPoint or Excel. Your data and chart must be part of your final PowerPoint presentation. So eventually you're going to have to put this data and chart in a PowerPoint. You can make it in the PowerPoint right off the top if you want. And so here's the directions on how to make it in the PowerPoint. Now you're going to choose a slide show for your PowerPoint. If you want to make the graph in the PowerPoint, your title slide shows up. Give it a title. You can add a subtitle or more descriptors if you want. You can even take a couple slides to add some information before you actually make your chart. But to make your chart, you're going to click on New Slide, which is up here. And then you're going to go to something that has a content. You can see in here these little icons. These are your graphing icons. So I'm going to go here, and it's this one right here that you want. This is your Insert Chart. You're going to click on Insert Chart. Then you're going to see over here you have all kinds of choices. You're going to choose the XY scatter plot choice. All right, and then go down here and click OK. Now what happens is it immediately kicks up this Excel sheet for you. Here's your X values, here's your Y values. I already went and copied all mine off of another chart, so you type them in. All right, so I have just 10 because I didn't want to make this go on forever. So there are my 10 values. My example was the number of hours spent in tutoring and the exam score. So the X values are the tutoring hours or the sessions, and on the Y values are the exam score received after X amount of tutoring hours. So once I do that, you'll notice all that information is down here. It automatically populates it for you. So you can click your X. Once you've got your information typed in, you can type it in or you can copy it. It just depends. If you're looking at it on paper, you'll obviously have to type it in. So this is what I have here. Okay, this is my graph. So now I'm over here on the plus. I'm going to choose, I want an axis. I also want the axis titles. I don't need a chart title because that's going to go up here in the actual slide title. And then I want grid lines. Data labels just tell you the value. You're welcome to put those in, but it gets messy because some of these points are on top of each other, so I wouldn't do that. And then legend just tells you that the dots are the Y values, which is pointless. You've already got your axis and titles and grid lines in there. So that's all you need to do. You can go ahead and click off of that. And the title for this is, for my total, I went ahead and chose a question: does tutoring improve exam scores? And then the subtitle for that, my title I chose was Exam Scores versus Hours Spent in Tutoring Session. So over here, you have to ask yourself what's dependent, what's independent. Do the exam scores depend on the hours spent in tutoring, or would the hours spent in tutoring depend on the exam scores? Now, exam scores could send you to tutoring, but you can't say this is my exam score, therefore I must have spent this many hours tutoring. It works the other way. So my independent variable is going to be my exam score. I'm sorry, my hours or sessions. I think it was sessions or hours. Each session is an hour. Session, or let's put hours. 1, 2, 3. Okay, my dependent or my independent variable is going to be my number of tutoring sessions, which were hour each. So I'm just going to say hours spent in tutoring. And then my independent variable is my exam score. All right, so there I've labeled each of my axes so someone looking at this will understand how these work together. Okay? What I've just done is followed these directions right here. Click on a new slide to choose a content slide, insert the chart, choose the XY scatter icon from the left and press OK, enter the data in the Excel sheet, close the Excel sheet, and then make sure you click on these and type the axis titles and the chart title in the slide box. Okay, now that's the end of the directions for a Microsoft PowerPoint chart. Now I'm going to go ahead. This is if you wanted to create the chart and copy and paste it. If you're really comfortable with Excel, these are the directions for doing the same thing in Excel. In Excel, you will notice the first thing you need to do is enter the data from your XY columns based on your independent and dependent variable, and then you make the chart. Okay, and when you do this, you want to make sure that you leave a place, well, you don't have to have a title. Leave a title. Yeah, you do need to. Okay. 1, 2, 3. 1, 2, 3. So I'm going to go ahead, again, I'm just pasting the data in. I left a spot on top to identify my variables. You can put X and Y, or you could, just to remind yourself, this was tutoring. This is the number of hours spent in tutoring, and this was the exam score, so that you know what you're looking at, okay? Now, once you've done that, you go ahead and highlight that, and then you're going to go to Insert up here on this tab, and you're going to choose the scatter plot diagram. And go ahead and click on scatter plot. It will automatically put in the data from your highlighted data. Right there it did that. Once again, you're going to click on you want your axis titles, you want your chart title and your grid lines. Okay, so my chart title based on before was tutoring, I'm going to make this short, tutoring hours versus exam scores. Okay, and then again, the y-axis was exam scores. Whoops, yeah. And the x-axis was tutoring hours. And you'll notice this doesn't type in right here. It's actually doing it up here, but once you push enter, it will put it in down there. So this is the same thing I had before. Okay, so whether you do it like this, in Excel or you do it as a PowerPoint, it doesn't matter. You're going to end up with the same thing. So either way is fine. Now looking back at our directions we've done, so I've showed you both examples. Once you've done this, you're supposed to check your plot for linearity and then justify whether or not you think your data is linear. Nonlinear data looks like this. This is a serious curve. This is a very big curve. Something this curved, you probably need to choose a different data set. But if it's got a little bit of a curve like that, then you know we'll live with it. It may not be completely accurate when you actually do your least squares regression, but that's okay. You just have to explain why your answer doesn't quite make sense when you extrapolate. Well, it's because it's curved. Linear data can look like any of this. The closer together the dots are, the better your line of best fit will be. So the more accurate the linear equation that you write to describe the data will be more accurate. The farther away the dots are from some kind of a line, the less accurate. That is called correlation. So the correlation is higher or more specific. Like this would be perfectly correlated. All the data falls on a straight line, so anything you want to say about that line or any guesses you make are probably going to be pretty accurate, and the correlation between your x and y variable is very high. This not so much, although this still isn't bad. I've seen somewhere that you couldn't even make a line out of it, which means the correlation is pretty bad. Okay? So let's go ahead and go in here. The next thing I want you to do is put 3 lines. If you look at your directions here, let's go to here. Check your scatter plot for linearity, then use the Insert Shape tool to electronically create 3 lines of best fit. Lines that look like to you that they go through a majority of the data or the points, all right? So you go up here, Insert, and you do your shapes. Where's shapes? There we go, shapes. And I'm just going to pick a line. And you need your line to go through at least 2 points, okay? It doesn't have to go through more than that, but it does need to go through at least 2 points. So let's go ahead and I'll have it go through, and this one's red, so I think I did it like this. I think all of the stuff went through here. Well, anyway, we can do this. I mean, these are just examples. You could do a line there, and then over here you choose it again. you want to have a different color so you can tell which one's apart. Whoops, I didn't draw my second line. You can go through this y-intercept and this point if you want. That's okay. Now it's going through, in this case, it looks like it's going through, no, it's not really going through this point, but it's going through the definitely your y-intercept. Okay, and then I'll pick another line and we'll let this one go through here. Okay, so I'm just randomly picking these. One thing you'll want to do, especially because when you print this out in black and white, it's not as easy to tell what you're looking at than originally, so I'll make this one green. So I would suggest here, up here, I'm going to shape outline to change the color. You can also go to dashes. And so if you want, if you change the line, like over here I went to dashes and now I have a dashed line. All right. Then I'll click on this blue one and I'll go to dashes. Up here I'm going up, just so you'll know, because I'm not sure how many of you have done this. I'm not at home. I'm over here where format is highlighted, and it's in format that you're going to find your shape outline tools. So let me go to weight here, and I'll pick a different dash pattern. I'll pick, let's see, let's do this dash pattern. This is obviously different. So this is a tiny dash, this is a bigger dash, and this is your solid line. And then you need to label these, like this will be your A, this will be your B, and this can be your C. So you need to draw your 3 lines of fit, and then you'd save it so they will stay there, and then you're going to proceed with your project. So I've just done that. Make sure that each line goes through at least 2 points so that you can determine the comparative slope. If you don't have 2 points, you can't find a slope. Okay, so interpreting your data. Interpret the data for each line in the context of your data. In other words, explain what the slope means in context. In my case, it would be tutoring hours and exam scores. Interpret the y-intercept of each line in context. In other words, once again, what does the y-intercept represent in tutoring hours and exam scores? And then write a linear equation for just one of the 3 lines, whichever one you feel was the best. You know, when you look at it, and this one definitely went through the data. Define a reasonable domain. You need to write a contextual word problem to predict your dependent variable, choosing a value within your domain but not included in your data. Okay, for the picture, just to be clear, the domain of this goes from 0 to whatever I said the domain was, all right? So you need to pick a point from somewhere in here. Remember, your y values are your dependents, so you're going to ask the question in terms of if I give you an hours, what would be the exam score? So you want to pick the number of hours within your domain. Say, you know, what would be your exam score if you had tutored 12 sessions or 12 hours? You'll notice that's not a point. Oh yeah, it is actually. Never mind. You need to pick hours that aren't on here. 13. 13 does not have a point with it, so you could use 13 hours or something. That's interpolation. Interpolation is where you pick a point within your data range. Extrapolation would be picking a point like what would be your exam score after 30 hours of tutoring, and then see what your y value or your exam score comes out to be. So that's what this means. With an interpolation, and then I want you to do something outside of your domain that's fairly far away, right here, fairly far away from your last domain value, so that you're really seeing, does this linear equation predict way in the future? Don't go like ridiculously far. If your domain stops at 20, 25, or 30, it would be fine. Okay, so when you do that, you're going to solve for your dependent variable using your chosen predictive values from part A and B. And this, again, remember, this is based on the one line you chose to be your line of best fit, and you've already written an equation, so you can answer these questions. Discuss the reasonableness of your answer for part A and part B. In other words, do the answers make sense? And you have to look at them separately because the interpolation answer may have different sense than the extrapolation answer may not make sense, and the interpolation may, or vice versa. Explain why or why not your answer for part B is reasonable. And one of the things that will depend on is the linearity of your graph. If your graph is curved and you're predicting something that's going to happen outside of the data set and it's based on a line and your data is not linear, then there's a really good chance that might be part of the reason why it doesn't make sense. And then you have to create a PowerPoint showing your graph and explaining your results from part 3 through 5. So that graph and the explanations are going to have to be in there. I'm now going to walk through an example or sample project that I've done between the correlation between tutoring hours and exam grades. So I went ahead and created the graph following the directions of, well, I don't remember. I did this a couple years ago, but anyway, I made the graph following the directions above, gave it a title, explained what was being measured, And then I went ahead over here is my chart. Now the reason I've put some of these in colors is I have 3 graphs down here. Because you were told to put 3 lines on there. I put the red line, the blue line, and the green line. And I made sure like the green line goes through, actually the green line goes through 3 points just kind of accidentally. Which is fine. It only had to go through 2, so you can use this point and this point for your slope, or you can use this point and this point. It doesn't matter. I'm pretty sure I used the last point here and the first point. The red line goes through this point right here and this point, and then the blue dotted line goes through this point right here and that point. So you can see it had to go through at least 2 points because you can't find a slope if it doesn't go through 2 points. And I've gone ahead and made different dashes and hashes for these lines so that if it printed out in black I could tell which was which, because otherwise there would be no way to distinguish, and it got a little confusing. So the first one is line A. The slope and rate of change is going to be based on your change in y over change in x. And again, I've made this red. So these are the 2 points on line A. This point was shared by line A and line B, so I've got both colors on this point. But it went through the point 1079 and the point 1888. My rise, the difference in my rise over my run, came out to be 9 over 8. And that's almost 1. 8 over 8 would be 1, so I put approximately 1. So in an exact slope definition, you would say increasing the number of tutoring sessions to interpret this. Your rise is your exam score, and your run is the number of tutoring sessions. So this is obviously increased, so that the exam scores are increasing by 9% for every 8 tutoring sessions that you went to. Or the exam will increase approximately using this approximation, approximately 1% for every 1 hour of tutoring. So an hour of tutoring leads to an hour of increase in exam scores, according to my data here. Line B, which is the blue one, has a steeper slope because it goes to the same point, but it started at a lower spot, so it should be a little steeper, and it is. This came out to 9 over 8. This is 16 over 9, which is almost 2. This is closer to 1. And this one, when I took the rise over run, again, that's the B colors here, this one and this one, when I took the difference between the rise, which is my exam score differences, over my tutoring sessions, I got 16 over 9 when I reduced it, which is really close to 2 over 1. So exact interpretation was increasing the number of tutoring sessions by 9 corresponds to an exam session increase, exam score increase of 16%. Or exam scores will increase approximately 2%, which is what you're 2, for every 1 hour of additional tutoring, something like that. C, I did the same thing again. I took the y minus y, I took the difference in y's, and these are all positive because the graphs are going uphill. And so this reduces to 17 over 9, and interpretation was if you increase your tutoring sessions by 9, you'll have an exam score increase of approximately 17%, or you'll increase 2 percentage points for every 1 hour of tutoring. And then you're supposed to check to make sure your interpretation of the slope is reasonable. Well, this seems really low that you spend an hour in tutoring, you only get an exam score increase of 1, but I didn't actually do this data, so I don't even know if it's accurate, but I just copied it off of something. But that seems a little low, so I would guess that potentially my line of best fit for the red is not going to actually be the right one, but maybe it is. Maybe you don't get a lot of bang for your buck when you tutor, and whoever was tutoring obviously wasn't doing a great job. So anyway, but they're reasonable. I mean, they're not saying something like your exam score increases like 90% for every hour or something. That would be considered unreasonable. You're supposed to interpret the y-intercept in context. In this case, there are 3 y-intercepts. I have a y-intercept at 50. If I look at my data, the second y-intercept was at 56. Now, the red line doesn't fall on a specific point, so I would guess that to be about 67. So this is 50. The interpretation is, look at your tutoring hours. You haven't been tutored at all. You're at 0. So the interpretation would be when you haven't gotten any tutoring at all, for this line, your score will probably be 50. That would be your score with no tutoring. Here, this line says your score with no tutoring would be about 56, and this one says your score without tutoring would be approximately 68, which could also explain why the slope is so low, is you already knew quite a bit, and so the tutoring's not adding a whole lot to your knowledge. I'm not sure if I believe that, but that would be a way to explain it. Now you need to look at your different lines on your graph and choose the one that you think models the data. In other words, it splits the data the best. It kind of is a good average of all the data. So I'm going to choose B as my line of best fit. If you look at A, it goes through these top points, but it leaves these bottom ones, they're very far away from the line. And what you're looking for is you want the average distance between all the points in the line to be about the same, to come out to an average. So the bottom points distance are averaged are the same as all the top points above the line distance. So it looks like B goes to the center of the data the best. So I'm going to pick B as my line that I'm going to choose of best fit, where I was just kind of guessing what looked right, okay? So the linear equation that represents the line B is modeled by G equals 16 over 9t plus 56, where 56 was my y-intercept and 16 over 9 is my slope. G represents the grade and T represents the number of tutoring sessions, and you need to identify this in your problem. And then I said, how was this equation created? Well, by using slope and y-intercept. If you didn't know the y-intercept, like for instance if A was your choice and it doesn't go through the y-intercept, you're going to have to use one of these points and your slope to find B, and then you can rewrite it, which is what we had to do in previous examples of linear equations. So if you don't have a y-intercept, you have to temporarily borrow a point and use your point intercept or your y equals mx plus b form to actually find B. Okay, so define a reasonable domain. What is the lowest number of tutoring hours? Well, I can't go below 0. Domain, remember, is my x-axis, and it has to make sure that any number you plug in for your domain gives you a y that also makes sense. Your range has to make sense or your domain doesn't work. So yeah, it makes sense to have 0 tutoring hours. These are all reasonable y values for my exam score. If I started at 0 and these lines were really stupid, really steep, and I ended up with a -6, that doesn't make any sense to start at 0 then. So if I had a line that went something like this, I would be in trouble because I wouldn't be in trouble, but I couldn't use 0 as my domain because when I chose 0, I was down here in a negative exam score. So you have to make sure if you use your lowest value for your domain, it gives you a y value that makes sense. In this case, it's not a problem. On this end, we need to, 18 hours, we're up to 90. And then you're going to follow this, and what you're looking for is when do you max out at 100? Because if you go beyond 100, unless your test has extra credit, you can't get anything higher than that. So at some point in time, tutoring hours aren't going to really help your grade according to this correlation because you can only get 100. So we'll look at that in just a minute. Now you need to define a reasonable domain. A reasonable domain would be represented by a realistic possible minimum maximum for the independent and dependent variable. The x is tied to a realistic values in the y-axis is what you're looking for. So I'm going to go ahead and pull this up as a Word document and put a line in here to show you when you would be careful. So let's say we had a line, shapes. Let's say that somehow our line went like this. All right, so let's say that was what our line looked like. In this case, 0 would not be a reasonable answer because based on this line, I'm getting a y value that's actually negative, which means I have a negative exam score, which doesn't make any sense. So 0 is usually your smallest value, but make sure it makes sense. If it doesn't make any sense, you don't choose 0. In this case, the domain, the lowest domain would be right here at about about 7. So this is not, I'm not saying that's the case here. I'm just giving an example of when you couldn't choose 0. In this case, you would say the minimum domain that would be reasonable is going to be when the number of tutoring sessions starts at 7, and then you would go from there. So make sure that you pick your 0. If you choose 0, make sure that 0 makes sense. So in this case, 0 does make sense. If I go to no tutoring for my line B, and actually all of these lines, my no tutoring says that I would get a score of 56 right at the top, which is perfectly reasonable. The question is, how many tutoring hours can I have or sessions do I have before I quit? Well, obviously, you have to stop some point in time. And what controls that is what your y values are. When do you get to a tutoring session where you go above 100%? Because getting anything above 100% on a grade, we're assuming there's no extra credit here. You're done. You don't need to go to tutoring hours beyond that. So I typed in 100 for grade. I entered 100, and then I solved for T. When I did that, I got 24 tutoring hours, gives you a grade of 100. So my domain would start at 0. In other words, you go to no tutoring, and then it ends at 24. According to this graph and this equation, when you've hit 24 tutoring hours, you're going to get 100 on your exam, so that would be the maximum of my domain. All right, so that's the reasonable domain here. Interpolation is when you choose something within your data and you choose something you don't know, I just put there 2. There's no points for 2. So I went ahead and asked, but that's within the 0 to 18 of the data I collected. It's inside the data range I have. So if Sam went to tutoring 2 times, you have to write your own word problem. What grade would he expect on his exam based on the linear regression equation? Then I went ahead and typed in a 2 for my tutoring times, and I got G was 59.7. So you would say the answer is 59.7% would be the grade he would expect after 2 tutoring times if this linear regression model holds. Extrapolation is where you pick something outside of your data range. If Sam went to tutoring every day for 4 weeks before an exam, which was 28 times, what grade would he expect on his exam based on the linear regression equation I have here? Well, if you type in 28 in for your tutoring hours, you end up with 108 as your grade, which doesn't make sense, and that's why you have to be careful with extrapolation and identify your domain, because if you're outside of the domain, you could get an answer that makes no sense. 24 hours is over here, and you can see based on this line it's going up. It's going to go over 100 pretty quickly, and at that point in time, you've got something that's, that doesn't make any sense anymore. So when you use data to interpret, you have to make sure you're paying attention to what are reasonable values. If this was a curve and not a line, if it went like this, if I typed in even 8, even 20, it would say my exam grade was here, when actually if I followed the curve it would be a lot higher. So that's why linear regression doesn't work very well on curved data, because it doesn't actually follow the data and give you a reasonable answer. So check for the reasonableness of both of these. And it's important to point out that association does not imply causation. Here we have tutoring hours tied or are associated with grade, but the tutoring hours don't necessarily cause the grade, because there could be other factors, like this person's already had, maybe you polled people that had already had math before or had high ACTs or something like that. So there's a high correlation here, but that doesn't necessarily mean it's you can say it proves that this caused it. So causation is different than correlation or association. They're not the same thing. Okay, so that's the end of this part. So you're going to have to present all 3 parts. Collect your data, make your chart. You're going to have to insert your lines. You're going to have to interpret your data. You're going to have to define, by your slope and your y-intercept, and pick one of your lines to be a line of best fit, and actually write in a linear equation for it. Define your domain. Write 2 contextual word problems using interpolation and extrapolation, and then solve for your dependent variable using your chosen predictive values from part A and B. This is all the contextual word problems. And once you've done everything, and again, you need to present this in the PowerPoint, what your conclusions were and why you got them, and this will be what you present.